This is Mr. Butler. I hope everyone is doing well and staying safe. And I miss you guys. And maybe we'll be back together someday. But for right now, I want to go over this worksheet. This was actually handed out before we had our before school was shut down. And I want to go over just the answers here and kind of walk through this a little bit with you guys. Just to kind of remind us here, our steps are the things that we need to be thinking about when we're writing chemical equations. We need to determine the reactants and products based on the description of the reaction that's given in the problem. Decide basically which side of the arrow everything goes on. We need the correct formulas. That's very, very important. We have to use our naming rules and remember diatomics and all that good stuff. Also, we need to include state symbols, solid, liquid, gas, and then remember that AQ for a solution, an aqueous solution, something dissolved in water. We need to insert the proper symbols. Plus signs separate multiple reactants and multiple products, and the arrow separates the reactants generally on the left from the products. The arrow points to the products on the right. And then lastly, of course, we have to balance the equation, which, as you recall, means we have to have the same number of atoms of every single element on both sides of the equation. Everything that we start with, we have to end with, and everything that we end with, we have to have started with. So let me flip back over to this assignment here. Like I said, you should already have this. Hopefully you have it with you, but even if you don't, you can see it here. And watch me kind of go through this. So number one here, reacting solid antimony with gaseous iodine produces solid antimony triiodide. So right away when we see that word produces, we know that what follows that, of course, is going to be the product. So antimony triiodide, well, antimony is the weird symbol SB. And triiodide, of course, means iodine 3, I3 of those guys, and it does say solid, so I can put solid in here, or S in here for solid. It looks like that is the only product, right? That's the only product. So what we are reacting, again, use the clues here to tell us what are the reactants and what are the products. We've got antimony in the solid state, and we have iodine in the gaseous state. Okay, there we go. Actually, let me undo that here. I made that a little bit sloppy. Here we go. So iodine in the gaseous state. Now you may or may not recall that especially when we have elements by themselves like we have for the antimony and the iodine, we always have to recall the Brinkelhoffs. And of course I'm mentioning that because it comes into play here, where iodine is one of these diatomics, which means that when it is by itself, not in a compound, but when it's by itself as an element, it has to have a 2 with it. So that was pretty ugly, so I'll try that again, but yeah, it doesn't really look much better. Anyway, that's an I2. So now we have correct placement of the reactants and products. Antimony and iodine are reacting. Our product, our one and only product, is antimony triiodide. And and we have the correct formulas for everything, including the I2 for the diatomic iodine. Now we just simply have to balance everything. Right now we've got that 2-3 thing going on between the iodine and between the iodine on the reactant side and the iodine on the product side. So an easy way to fix that, you recall, is if I put a 2 out in front here. Remember, the only thing I'm allowed to change here when I'm balancing are the coefficients out in front. That's the only thing I can change. And so if I put a 2 in front of the SBI3, that gives me 6 iodines. And if I put a 3 in front of the I2 over here, that gives me 6 iodines over here. Now, another thing that happens is when I put that 2 in front of the SBI3, that also gives me 2 antimonies, 2 SBs, but I can fix that easily by putting a 2 over here. And now it should all be balanced up, right? 2 antimonies on both sides, 6 iodines on both sides, and I've got my state symbols. Everything's balanced. Okay, let's move on. Solid ammonium carbonate is the active ingredient in smelling salts. When solid ammonium carbonate is heated, carbon dioxide gas, water vapor, and ammonia gas are produced. So this one's a little bit different. It's a little bit odd looking because when we go to look at what are the reactants and what are the products, well, there's really only one reactant. We are going to heat up that ammonium carbonate. So ammonium carbonate, ammonium is one of those polyatomic ions. It's the only one on our list that's positive, and it is a +1. And carbonate, CO3, another polyatomic ion, is a -2. And so that means we need 2 of those +1s, which means we need to put parentheses around this and put a 2 right there. And it also tells us that it is solid. Okay? On the product side, we've got carbon dioxide gas. Everybody knows that formula and state symbol. And water vapor. Remember that word vapor. Of course, we all know water is H2O, but that word vapor, it means gas, right? And also ammonia gas as well, NH3. Notice I gave you that formula because I wouldn't expect you to know the formula based on the name. That's one of those where the name doesn't really follow the formula or give you the formula. And that also is a gas. This one is an easy one to balance, but it doesn't look like it's easy. It turns out that, well, if we look at carbon is actually balanced right now, 1 on each side. Even the oxygen is okay. We have 3 oxygens on the reactant side. We have 3 oxygens on the product side. What's out of balance is the nitrogen and the hydrogen. And so if I look over on this side over here, I've got 2, this 2 outside the parentheses here gives me 2 nitrogens and 8 hydrogens. And over on this side, I've got nitrogen and hydrogen both right here. So it turns out I can fix both things with one move here. In order to get my 2 nitrogens, I'm going to put a 2 in front of this. That gives me 2 nitrogens right there and 6 hydrogens, but I've also got 2 hydrogens over here in the water for a total of 8. And so now this guy is balanced. Okay? On this next one here, number 3, liquid methanol may be synthesized from, okay, even though this is listed first, this is actually the product. May be synthesized from, in other words, it comes from, it's made from carbon monoxide and hydrogen gas reacting. So our reactants over here, carbon monoxide, mono means 1, right? And hydrogen gas, remember hydrogen is a Brinkelhoff up here. And so hydrogen is an H2, and it's also a gas. And our one and only product this time, and the last one we had only 1 reactant, this time we have only 1 product, is CH3OH. Again, another substance that I gave you the formula for because I didn't, you wouldn't be able to get it just from the name. And that is in liquid form. Okay, so if we look and see what is not balanced here, it turns out that our hydrogens are out of balance, right? On this side, even though it's in kind of in 2 different places, I've got 4 hydrogens. Over here on the reactant side, I only have 2 hydrogens. So I can fix that very easily by slipping a 2 right there. Okay. Number 4 here, calcium metal is added to liquid water. So right away, that sounds like, that's the reactant side, right? That's what we're putting together. That's what we're mixing together. And then, of course, we have some more clues here. Hydrogen gas is given off, and the water turns cloudy, right? Why does it turn cloudy? Because of solid calcium hydroxide. So again, when we identify those reactants and products, look for those context clues. Calcium metal, that's going to be a solid, right? And added to water, liquid water, so that's going to be L. And our products are hydrogen gas is given off, right? Again, hydrogen's a Brinkelhoff, so we have to have H2, and the other product is that cloudiness comes from that calcium hydroxide. And remember calcium, and we've got hydroxide here. Calcium is a +2 charge. The OH, the hydroxide here, OH, is a -1, so that means we need 2 of those guys, which means we put that in parentheses and put a 2 outside. And then that is solid calcium hydroxide. So The 2 outside the parentheses here, remember, again, that means 2 oxygens and 2 hydrogens with that calcium hydroxide. Plus we have 2 more hydrogens over here. So we've got a total of 4 hydrogens on the product side, right? 2 there and 2 more over here. We only have 2 hydrogens on this side, but we can get 4 by putting a 2 out in front, of course. That gives us our 4 hydrogens. But it also gives us 2 oxygens. But we're in luck because we already had 2 oxygens right here. This 2 goes with the hydrogen and the oxygen. So this guy, I believe, is already balanced, right? 1 calcium on each side, 4 hydrogens on each side, and 2 oxygens on each side. All right, I think I need to scroll up a little bit here. And let's see here. Can I still? Okay. Ooh. There we go. And pin back. There we go. All right, number 5 here. When magnesium metal is heated strongly in a crucible, it can react with. Okay, so obviously right away it's telling us right there that the magnesium metal, again, that's going to be a solid, is reacting with nitrogen in the air. So that's obviously a gas. Also, you may recall, nitrogen is one of those Brinkelhoffs, so it needs to have a 2 as well. And it is producing, right, solid magnesium nitride. So magnesium nitride, let's see, magnesium is in the second column, so it's a +2. Nitride is 3 blocks away from the noble gases, so it's a -3. So we've got a +2 and a -3. So we do that thing that we've done 100 times, and that is 3 of these guys and 2 of these guys to balance out those charges. So now we need to balance, this is solid, so we need the S there for the state symbol. Now we look at the balancing here. We've got 2 nitrogens on both sides already, so that's good. We've got only 1 magnesium over here, but 3 over here, so we can very easily fix that with a 3 right there. Okay? Moving on here. When you neutralize a solution of sulfuric acid by adding a solution of a strong base like sodium hydroxide. So again, from our context here, we can see that the sulfuric acid and the sodium hydroxide are the reactants. And it even says here are produced, right? Liquid water and sodium sulfate are produced. All right, so you may not remember how to name acids. Remember, acid, first of all, means hydrogen cation with a +1 charge. No hydro in the name means we're looking for something that has oxygen in it. Sulfuric tells us that what we're looking for is sulfate, right? Remember, I ate the acid and said ick. Now, the sulfate ion is a -2 charge, and the hydrogen is a +1. So to balance those out, I need 2 hydrogens, H2SO4. Acids are solutions. I guess it says it in the problem as well. And that is reacting with sodium hydroxide, sodium +1 in the first column, hydroxide -1, polyatomic ion, and it is a solution as well. And what is being produced is liquid water, so liquid water, and a solution of sodium sulfate. So sodium sulfate in A is a +1, sodium is a +1, sulfate, SO4, is a -2, so that means we need 2 of those sodiums, and that is a solution, and that is AQ, all right? I think this is the first problem on this page that we've had the AQ symbol for, but that means solution or dissolved in water, solution in water. Okay, so now for balancing, we have to look at what's not balanced already, right? This one, again, is one of those that looks more complicated than it really is. What it kind of boils down to is that we've got 1 sodium over here and 2 sodiums over here. And so we can fix that pretty easily by dropping in a 2 right here, right? Remember, coefficient is the only thing we can change. And so now we've got 2 sodiums. And if we count up everything else here, we've got 2 hydrogens over here, and this 2 out in front gives us 2 more hydrogens over here. So a total of 4 hydrogens on the reactant side. And on the product side, 2 here and and that's it. So now we need to balance that out by putting a 2 here. So now we have our 4 hydrogens on both sides. Now let's look at the sulfur. 1 sulfur on this side, only 1 sulfur on this side. Oxygen. We've got 4 oxygens right here, but another 2 more over here, right? Remember that 2 out in front gives us 2 oxygens. So 6 oxygens on the reactant side. On the product side, again, we've got a 2 in front of the water, so 2 oxygens here, plus 4 more here gives us a total of 6. So that one is balanced out now as well. Okay, moving on. Iodine crystals react with, so again, pretty obvious there. What are the reactants and what are the products? So iodine crystals, crystal means it's going to be in the solid state. And it's also one of those diatomics, as we saw earlier. Well, that was really ugly. Let me try that again. I'll just start that one over. So iodine 2, and it is solid. There we go. Reacts with chlorine gas. Now, chlorine is also a Brinkelhoff, right? It's also a diatomic, so it needs a 2 as well. And that is in the gas state. And that is going to produce iodine trichloride. So iodine, no prefix on the iodine, means 1, and trichloride means 3 chlorines. And that is in the solid state. So now when we look at what we've got here, we've got 2 iodines on the reactant side, but only 1 over here. And with the chlorine, we've got that 2-3 thing going on here. So we can fix that by putting a 2 out in front. That gives us 2 iodines, which is what we needed on the reactant side to match the reactant side. And now we have 6 chlorines, and I can get 6 chlorines on the reactant side by putting a 3 there. So that should balance that one out. Okay. This next one here, I don't have a lot of space here, but I'll see what I can do here. When a piece of steel rusts, iron metal reacts with oxygen. So again, no real secret here that iron solid, right? Iron metal is going to be a solid. Reacts with oxygen gas. Oxygen again is a Brinkelhoff, so it needs to have the 2, and it is producing iron 3 oxide and iron 3. Remember that Roman numeral 3? I think this is the first Roman numeral we've had on this page. Roman numeral 3 means a charge of 3, right? So we've got plus 3 on the iron, and the oxide is 2 blocks away from the noble gas, so it's a negative 2. So if the iron's a plus 3 and the oxide's a negative, and the oxygen's a negative 2, we've got Fe2O3 as the formula there to balance out those charges. Remember, that's really important to get those correct formulas. Otherwise, the balancing, it might not even balance at all. But even if it will balance, the balancing won't be correct if the formulas aren't correct. And a lot of times, like I said, it won't even balance at all if you don't have the correct formulas. This is in the solid state, so there we go. Now, we need to balance here, right? So if I look at, again, I've got two irons on the product side, but only 1 iron over here, so I might try to put a 2 there, okay? But I've also got 3 oxygens on the product side, but only 2 oxygens on the reactant side. So that's that 2-3 thing that we run into a lot, and of course we know the way to fix that is I've got to put a 3 here to make that 6 oxygens, and if I do that, then I got to put a 2 here to make it 6 oxygens over here. Well, that messes up my iron, right? And this will happen sometimes. When you fix one thing, you kind of upset another thing. Or when you think you have something fixed, you have to fix it again if it gets upset by something else. So no big deal. We just have to kind of cross out the 2 there and make it a 4 instead. When I put that 2 in front of the Fe2O3 over here, that gives me 4 irons on that side. Okay, so let's see if I can get to the last one. I'm not sure if I can, it's not going to let me edit for some reason. Okay, here we go. I may have to, oh boy, I don't have a lot of space here. I'll just do it where I can here. All right, I'm going to pin back here. So it says liquid water and solid aluminum fluoride are formed. Okay, you can't see it on the page here very well, but I can read it off my paper here. So those are the products. I'll just write it above here. They are formed when solid aluminum oxide reacts with hydrofluoric acid. So we've got the reactants are aluminum oxide. So again, aluminum is a +3, oxide's a -2. So we've got that Al2O3, that 2,3 business that we seem to like so much. That is solid, and that is reacting with hydrofluoric acid. So remember we said that acid means hydrogen plus 1 cation. Hydro in the name means we don't have oxygen. So hydrofluoric means the anion must just be fluoride. And so fluoride is it's a halogen. Fluorine's a halogen, so it's a -1. So we've got a +1 charge and a -1 charge. So that guy is balanced as is. Now I don't think it says it in the question here, or in the problem, but anytime you have an acid, that is always going to be an AQ. An acid really isn't an acid until or unless it's dissolved in water. So even if it doesn't say solution, anytime you have an acid, it's going to be a solution, an AQ. The products again are water, and that is liquid water. So L here for liquid water. And the other product is aluminum fluoride. Aluminum remember it's at the top of that diagonal. It has a +3 charge, and fluoride is a -1. So the formula here is AlF3, and that is in the solid state. Okay, so now when we go to balance, let's see. Oh boy, we got a lot of things going on here, right? We've got 2 aluminums on the reactant side right there, but only 1 aluminum over here. So that might be something we want to try to fix. So I can fix that by putting a 2 out in front over here. So now the aluminum's okay. But now I got a lot of fluorines, right? I've got 2 times 3, 6 fluorines on the product side over here, and only 1 fluorine over here on this side, on the reactant side. So if I'm going to even those up, I need to put a 6 right here. So if I put a 6 there, that gives me 6 fluorines, but it also gives me 6 hydrogens. Okay, so now if I go back on the product side, well, I've only got 2 hydrogens here in my water, and so that means I must need 3 waters in order to get those 6 hydrogens, but that also gives me 3 oxygens. So on the product side, right? That 3 out in front multiplies by the oxygen. So now if I look back on this side, on the reactant side, I have 3 oxygens over here. So I think everything's in balance. So let me double check. I've got 2 aluminums on the reactant side and 2 aluminums on the product side. I've got 3 oxygens on the reactant side, and I've got 3 oxygens on the product side, 6 hydrogens on the reactant side, and 3 times 2 is 6 hydrogens on the product side, 6 fluorines on the reactant side, and 2 times 3 is 6 fluorines on the product side. So that one is all balanced. Okay, guys, I think we are all done with that worksheet. What I'm going to have you do is work on the one that I sent out as extra credit. If you have already worked on it and turned it in by Monday, by the end of the day Monday, you'll still go ahead and get some extra credit on that. But I'm going to go ahead and make the first 4 problems, just the first 4, 1, 2, 3, and 4, as the assignment for tomorrow. Okay? Good luck and stay safe, and I'll talk to you soon.